Hey everybody, welcome back. Today is day 6 of our geometry summer skills. For today, make sure that you have your handy dandy calculator. We're going to be using this one more time. You make sure you have some highlighters. They're going to be helpful, and your day 6 note packets. If you got everything there, without further ado, let's jump right into it. All right, today we're going to be taking a look at your day 6 notes. So trigonometry to find missing angles. Now, I crossed off the goal inside of that think bubble because I forgot to fix that one. All right, here's our goal for today. Given a right triangle, you will be able to use trig to solve for missing angle and side measures. Now, on day 5 notes, that's where we solve for missing side measures. So today, we're going to be focusing on finding missing angle measures. And a lot of students say, hey, finding a missing angle is a little bit easier than finding a side. So by the end of today's lesson, I'd like to know what you think about that. All right. So when you're using trigonometry to find a missing angle measure, so here are the steps. Number 1, you have to make sure that it is a right triangle. So trigonometry only works with right triangles. The second thing is you have to make sure that your calculator is in degrees. Now, we changed this yesterday, but just in case, a little reminder is you need to hit the on button. You hit the mode button, which is right next to the blue button, mode. And then you want to make sure that the word degree, all right, is highlighted, not the word radian. If you've got that, then you hit the second button and then hit the mode again, and you're back to your normal screen. Okay, so we are in degrees. Step number 2, circle the angle you will be using and label your sides as opposite, adjacent, and hypotenuse. Determine which trigonometric function you will use and set up an equation. And now here's the interesting part. To find a missing angle measure, so only for angles, we use what's called the inverse function, which is sine to the -1, cosine to the -1, and tangent to the -1. Now, if you look at your calculator, those functions are above the word sine, cosine, and tangent. So if I zoom in here, all right, if you see sine, cosine, and tangent, the inverse is directly above it in blue. So to get that, instead of just hitting the sine button, you hit the second button and then the sine button. And if you look at your screen, all right, now you see that it says the inverse, and then we'll put the function into that parentheses there. Okay, so that's how you get to the inverse. All right, so let's jump into it and let's give this a try. So example number 1, for each of the following triangles, show your work to find the value of theta. Now theta just means it's a missing angle measure. Round to the nearest tenth. Okay, so if we look at our very first triangle, the first thing we need to notice is that it is a right triangle. So I have a missing angle and I have 2 sides, which means we can use trigonometry. So I'm going to circle my angle. And now I'm going to label my sides. So the 72, that is opposite the 90-degree angle. So this is our hypotenuse. And then if I look at the 42, it's directly across. It's not next to angle X, it's across from it. So that would be your opposite side. So now we have to remember that phrase from our last lesson, which was so, ka, toa. So sine, cosine, tangent, and then opposite hypotenuse goes with sine, adjacent hypotenuse with cosine, and opposite and adjacent with tangent. So if we look at what we have here, we have opposite and hypotenuse, which means we're going to use sine. So we're going to write this in, sine. Now remember, what goes next to the word sine is the angle. So our angle is X. It's not an angle measure. Is equal to, and then it's OH, so opposite 42 over hypotenuse, which is 72. Now, since the sine is connected with the X, we can't type in the calculator sine X because we don't know what X value is. So what we need to do is we need to move the sine to the other side. But in trigonometry, you can't just move it over. Instead, what you have to do is do the inverse. So x is going to be equal to inverse sine. So when you move sine to the other side, it becomes inverse. And then we type in 42 over 72. And now this is what we're going to type in the calculator. So I hit the second button and then the sine button. And then on my screen, I see that it says inverse sine. And now we type in the fraction, which is 42 divided by 72. So our angle is going to be 35. Now it says to the nearest tenth, so that means 1 decimal. So that would be the 6. Look at the number behind the 6. It's an 8, so that 6 will round up to a 7. So x will be equal to 35.7 degrees. And we have got it. Now, some of you in your class last year may have realized, well, do we really have to write this step out right here? Nope, I'm just trying to write it out so you know exactly what you're typing in the calculator. But if you get to this step and you know to use the inverse, you can right away just plug it in. Okay, so let's take a look at example number 2. So again, we want to find the value of the missing angle, which is either theta or x. And here we have an x. So I'm going to circle it. It's a right triangle, which means the 13 opposite the 90 is our hypotenuse, and the 11 is directly next to the x. So that would be our adjacent side, and the opposite side has no number value, so we're not going to use it. So we have an A and an H, so I look at SOHCAHTOA, and it's the C that uses the A and the H. So that means we're going to use cosine. So we write down cosine of x equals adjacent over hypotenuse, which would be 11 over 13. Now this next step, I'm going to write it down, but this is the step you can just do in your head. When you move cosine to the other side, it leaves the x, but it becomes the inverse cosine. And this is what we're going to type in the calculator. Okay, so back to the calculator, you hit the second cosine, and then 11 divided by 13. And our angle measure to the nearest tenth is going to be 32.2. Look at the number behind the 2. It's a 0, so that means the 2 is going to stay the same. So 32.2 degrees is our solution. Okay, let's move down then to example number 3. All right, again, it's a right triangle. Our missing angle is theta. All right, so now let's label the sides. Opposite the 90-degree angle is our hypotenuse. And the 2.4 is opposite. And the adjacent to the side we don't know. So then we remember SOHCAHTOA. So we have an O and an H, which means we're going to use the sine. So sine of theta, now theta is just like a 0 with a little bar in it, equals opposite 2.4 over hypotenuse 3.8. All right, so now I'm going to go right to my calculator this time because I know if the angle is missing, I have to use the inverse. So I'm going to hit second sine, and now I'm going to type it in. So 2.4 divided by 3.8. And we hit enter. To the nearest tenth, we're going to get 39 point, so there's a 1. Look behind the 1. Is that second number bigger than 5? Yep, so that 1 rounds to a 2. So this would be 39.2 degrees. All right, up next, what I'd like you to do is go ahead and find the missing angle. Actually, what I want you to do is just label your sides, and in the computer, it's going to ask you, are you going to use inverse sine, inverse cosine, or inverse tan? I'd like you to take a moment and choose which one you would use. All right, so we've got adjacent and hypotenuse, which means we're going to use cosine. And cosine is going to be 88.3 over 117. So then we hit second cosine, and that's going to be 88.3 divided by 117. We hit enter, and we get 41 degrees. And we have got it. So ladies and gentlemen, that is how we use trigonometry to find missing angles. So what do you think? It's a little bit less steps than finding a missing side. All right, so next up, we are also going to have to work in word problems to find missing angles using trigonometry. So that's what I have for the next few examples here. So number 5, it's a word problem, so let's put the pencil down and let's just read through it once, and then we'll read through it again and mark the picture. A ladder 14 feet long rests against the side of a building. The base of the ladder rests on the ground 2 feet from the side of the building. What angle does the ladder form with the ground? Round to the nearest whole degree. All right, so based off of this question, I know we're trying to find an angle measure. So now let's go back to the beginning and let's put as much information into the picture as we can. So a ladder is 14 feet long and it's resting against the side of the building. So here's our 14. The base of the ladder rests on level ground 2 feet from the side of the building. So here, this down here at the bottom, the ground, the ladder is 2 feet away. So this would be a 2. What angle does the ladder form with the ground? So the ladder and the ground. So this is the angle we want to find. I'm going to put my X there. All right. Now we do have to realize that a wall in the ground is always going to make a 90-degree angle, which means we have a right triangle. So to find our missing angle, we can use trigonometry. So just like before, circle your angle, and then we're going to label our sides. So the 14 is opposite the right angle, so that's our hypotenuse. And the 2 is directly next to the X, so that's our adjacent. So now we're going to remember our SOHCAHTOA. So if we have an A and an H, that's going to leave us with cosine. So cosine of X is equal to 2 over 14. So remember, when the angle is missing, okay, we can't type in the calculator cosine X. So we have to do inverse cosine. And then we type in 2 divided by 14. We hit enter, and our angle is, let's see, where do they want us to round to? The nearest whole number. So what's the nearest whole degree? Well, 81.77 is bigger than 5, so that rounds that to 82 degrees. All right, number 6. All right, for this one, I'd like you to try this one from start to finish on your own and go ahead and put your answer in. All right, so let's see. Did you end up using tangent? And then you would get 25 over 120. Plug it in the calculator, and we should get 12 degrees. If you got that, you're good to go. All right, so finding an angle using trigonometry. All right, you just still follow the same steps using SOHCAHTOA, but this time there really is no solving or solving a function. Here, you just really just type it in the calculator using that inverse. Now, when trig gets a little bit more complex is when your questions are mixed up, finding a missing angle and finding a missing side. This is when we have to do a little bit more critical thinking to know which method we're going to use. So what I'd like us to do next is just practice a few questions where we have to make the decision if we're going to find a missing angle or a missing side, and then know which way or which method to use to solve. Okay, so remember, if you are missing a side, you're going to use regular sine, cosine, and tangent. If you're missing an angle, that's when you're going to use the inverse sine, inverse cosine, and inverse tan. Okay, so let's try the next few questions, taking our time and trying to figure out what we're going to use. So question 7. A tree casts a shadow 31 feet. At the time the shadow was measured, the sun had an angle of elevation of 62 degrees. How tall is the tree? Okay, so if we want to know how tall the tree is, that's a missing side. So this means we're going to use regular sine, cosine, or tangent. So let's go back and make sure we have everything in the picture. A tree casts a shadow 31 feet long. There's the shadow. At the time the shadow was measured, the sun had an angle of elevation of 62 degrees. That's in the picture. How tall is the tree? So our x is the height of the tree. And then remember that when you take height, it's always perpendicular. So it's a right triangle. So whenever using trigonometry, we circle our angle and then we label our sides. The x is the opposite side and the 31 is the adjacent. So if I think of my phrase, so, ka, toa. All right, we have no hypotenuse, so it's not sine, it's not cosine, so we're going to use tangent. So now we type in tan. Now the angle is 62, and remember, the angle measure goes directly next to the trigonometric function. Equals opposite, which is x, over adjacent, which is 31. Now, this time, because we have the angle measure, we can type it in the calculator. So tangent of 62, we hit enter. Now this is just a number, so I'm going to write that number down. 1.8807 equals x over 31. Now we have a number equal to a fraction, so I put that number over 1, and now we can cross multiply to solve. So 1 times x is just x is equal to, and now I'm going to do 1.8807 times 31, and our tree is going to be 58, now to the nearest tenth, 0.3 feet tall. And we have got it. So this question, because we were missing a side, we had to type regular tan into the calculator. All right, let's flip it over and let's see what we got. Number 8, a man is flying a kite with a string that is 75 feet long. If the angle that the kite string makes with the horizontal line to the ground is 35 degrees, how far above the ground is the kite? Round to the nearest whole number. Okay, so a man is flying a kite and the string is 75 feet long. The angle that the kite string makes with the line horizontal to the ground, so here's the ground. Now the kite string in the ground, so I got to extend my kite string, so here we go. This is going to be 35 degrees. How far above the ground is the kite? So here we go. X. So the height is going to be the vertical height, which means it's perpendicular. So this time we're missing a side measure. So we're going to use regular sine, cosine, and tangent. So I'm going to remember so, ka, toa. All right, so let's circle the angle, and now we label our sides. The x is opposite, and the 75 is the hypotenuse. So if we have an O and an H, we're going to use sine. So I'm going to write this as sine of 35 degrees is equal to x over 75. Now we have the angle measure, so we can type that right into the calculator. Sine of 35, and we hit enter. And now I'm going to keep 4 decimals, so 0.573. Now that 5, the number behind is a 7, so that changes to a 6. 0.5736 equals x over 75. A number equal to a fraction, we put the number over 1 because now we have a fraction equal to a fraction and we can cross multiply. Now 1 times x is just x is equal to, and now I'm going to multiply across. So 0.5736 times 75, and the kite to the nearest whole number is going to be 43 feet above the ground. All right, so let's go ahead and we're going to skip number 9. I feel like you've done enough of these questions. What I'd like you to do, though, is take a look at number 10. A jet airplane begins a steady climb of 15 degrees. and flies for 200 ground miles. Okay, what is its change in altitude? Round to the nearest tenth. All right, so what I'd like you to do is go ahead and try this problem on your own. So we have a right triangle, we have our angle measure. Okay, so we mark our sides as opposite, adjacent, and no hypotenuse. So we remember so, ka, toa. So now I'd like you to take a moment and try this on your own. Okay, let's see how you did. Did you pick tangent? All right, and after you cross multiplied, were you able to get 53.6? If you did, you have got it. All right, ladies and gentlemen, as a reminder, if you have any questions on today's lesson, or if you weren't able to get any of the practice problems on your own, please log back on to the Google Meet. I will be there until 11 a.m. today. And at this point, if you don't have any questions, you can flip over to the next page. You have 5 practice questions right now. When you're done with them, make sure that you submit your solutions on Google Form Day 6 practice. All right, ladies and gentlemen, I hope you have a great rest of your week. Just as a reminder, I'm here to answer any questions that you have. Okay, bye-bye.